Definitely data oversight.
You didn't spell.
I'm.
Can you hear us now?
I fixed it.
Okay, can you hear us?
Anybody-
So
You speak, it goes over to you.
Gotcha now.
thing is, I want to go back to just kind of reemphasize, Mike was talking about a data product that he built in Harvard that had fire occurrence data from Informed, fuels data from Edge, data from the NIMSI open data site,
Fuels moisture data.
fuels moisture data. So basically what he had done is all of these proof of concepts that we've been working on all along, right? So the fuels moisture data, that was the first one. Then the reference data from Edge, and then the fire occurrence data. Then they built a time dimension. All of that is linked together in a way that you can go in and now slice and dice, ask questions about fire occurrence data in relationship to this fuels model or in relation to local time or relation to, you know, and so I just want to, that's like the goal, right? That's what we're trying to get to, is that you have access to this data, and it means that each of the applications that are authoritative for parts of the data that we use in the big picture, right? Like you get to just focus on your business area. So the work that you have to do to support the business processes you support. And as we start evolving this, we'd be able to start lifting that analytic burden off of you. That instead of people going to your database and running queries against your database that is trying to support transactions that support your business processes, that analytic weight is done at the IBME level. So those queries, if they're pulling data from multiple sources, they want to run big queries, like we're managing that for you. So you don't have to do that for your application. You have to make that part of your management of your application. And so that's a benefit, we think, to the applications, and the benefit to the users is that we follow business rules that implemented through governance processes like NWCG committees, the data management committee, the data management program with it, you know, whatever, that then ensures that the data is, you understand the state of the data that for your processes. And the cool thing about it is that we can have business rules that are different, like for BLM versus BIA, right? Like we can accommodate that type of stuff now in a way that was really, really difficult to do before. And so it just helps us evolve how we manage our data at an interagency level and how we interact with the various partners that participate in that. And so I just wanted to kind of circle back to that, because I think we kind of went through that pretty fast, but that's really the big thing, right? Fire occurrence, you know, et cetera. So.
So I know we use the term buy, but I don't believe we're actually talking about money when we're saying buy, or we could be. But my curiosity is how much this is going to cost the community or not. Because I know a lot of what we're talking about is going to be requiring a ton of storage space. I know, like for Irwin, we have X amount of cost that we got to pay for cloud hosting. And then like when Inform was working off of Irwin, they paid Irwin a certain amount to use that cloud space. So all of this that we're talking about is going to drive up and a substantial cost exponentially, especially the more data you get. So is this all going to be funded by one specific agency, or is this going to be a cost to the broader community of who uses it, of whoever gets a dashboard? Like, how is that going to work out?
Yeah, I think that those are good questions. So, so there's a couple of paths around that. So yes, there is a cost that's associated with storing the data. One of the things that I really like about the Snowflake model is that it stores the data differently. Carlos could explain the rows versus columns kind of thing, but what it allows is them to compress the data so that it doesn't cost as much for us. And so they've got really good use cases, and customers that have shown, cost savings because what they had in the cloud, Snowflake was able to compress and it reduced their storage costs. So it's like really efficient that way. But yes, there's cost associated with that. So that's one aspect of it. The other is, so on the program board, we talked about the NIST open data side. And, we anticipate some increased costs related to that because of some, well, first of all, Esri didn't build HUL for, 25,000 users. So they're kind of like, so there's probably some increased costs going to be coming down the path around the NIST open data site. And so I think we're going to be having some conversations about when we have something like NIST that is like kind of the backbone for Inform and for Irwin, there's like how do we manage those costs? And I see IDME that same way. Like if we're able to produce cost savings for applications, is there a buy-in for that? I don't know. I have no idea how that. Our traditional model is we have a managing partner, and maybe that multiple people will contribute funding to that, but that managing partner is where that funding comes from. I'm sure that there's a layer of that that's going to always stay the same, but yeah, how we handle costs for these types of things across the enterprise and across applications. I think I'm looking at our program board rep here. Say, we can know that one, Chris, because I think we do need to think about that. But at this point in time, we're looking at it as a project. It's funded, and Forest Service is the managing partner. There is Forest Service funding available, and we'll see the BOI contributions may or may not be made. How we balance that out. Okay, Chris, should speak there.
Totally agree.
Okay. As long as I'm not in trouble with Chris, I'm good. Okay.
My question was more about the linking within the systems of the district data sets. Are you going to be using existing keys that are across those data sets? Do you create new ones? I'm just wondering how that's kind of done.
Yeah, a little bit of both.
Okay.
It kind of depends on what zone you're talking about. The analytics zone typically will use surrogate keys. But we'll also include the original business keys in the table. For both.
Okay. Great. Thank you.
Yeah.
We also want to talk about the workload.
Yes. Like what the different impacts on the applications for us to get their data. As sources.
Yes, I guess I can speak to that because it's, it's quite varied, I guess, based on the type of application it is and what you're doing today. We might be acquiring data directly from the database. We might be getting it through an API through some kind of bulk refresh processor, things like that. So there's a lot of different choices. So I think in any case, the work you would have to do would require fairly immediate access, some kind of access, usually read-only type of access, but there's usually a process, right, to be able to get access to the lead data. And in some cases, we're not necessarily looking at reading data from the whole database, right? It's maybe just key places in the database that might be at least part of the use case or important. At that point. So it really depends on every application. The answer is a little bit different. But generally speaking, what we try to do is we try to access the data as little as possible and impact the application as well as we can. So, for example, if we're running on an incremental data load schedule, let's say 24 hours. So every 24 hours, the job kicks off and it goes to your application to grab some data. It tries to grab only the relevant data and only the data that's been updated or changed since the last time we did it. So, if you've got a large database, you're accumulating data every day and changing data every day. You might have a key table that has 100 million rows, but maybe only 25,000 actually changed yesterday. So the idea is to try to grab only what's needed and nothing more. And now how do we grab that? If you already have a process where it's beneficial for us to kind of leverage that, we will. So in today's cloud environment, for example, a lot of people might, let's say you're on a MySQL database, you might have a MySQL replica running already, because that's kind of a common practice. You might have 2 or 3 replicas for read purposes. So we would want to be able to hit one of those replicas that would not impact the primary database being updated. Wouldn't slow anybody down if you're trying to update data or add data or anything like that. If you don't have a replica, you might have replication turned on if it's native Oracle, SQL Server, that kind of thing. You might have change data capture already running. Any of those things are always better because those things don't allow us not to hit the source database, right? Anytime we have to hit the source database, if that's the only choice, and again, in today's world, that's often not the choice, but if it is, we would only hit it in a read-only mode, so we would never lock it at the table. We would never like put an update lock, an exclusive lock on the table, on the record, or anything along those lines. Anything that would benefit us, we would use, for example, if you timestamp data, that's always a benefit. If you don't timestamp data, we can use the log sequence number and try to pull the data from the log. So for example, in a situation with Matillion, and we're pulling data from Postgres, another situation we have where Postgres is in AWS, it's the Postgres Aurora. We're able to use the log sequence number, and that'll tell us any record with the log sequence number grade, this has changed. So we know that we only need to get those records, right? And then we track it ourselves. When was the last log sequence number we used, and the next time we come and pull, we start there. So the impact is very small, especially if you're already in a cloud environment. It's very, very small, right? It's you probably already have a Postgres, MySQL, even a SQL Server, some kind of replicas running, or maybe some kind of a place you back up the data to that we could use or copy it to, or that sort of thing. On the other hand, in some cases, we don't have much of a choice. We do hit source databases if that has to happen. But again, we try to use as many techniques as we have. So we're not doing table scans on all your tables every time and blocking everything else, blocking people from doing their work. If it's APIs can be difficult because APIs are often written by applications that share data with other applications, not with business intelligence and big data systems. So I would love an API that said, hey, give me all your customers, new customers from yesterday, right? And it gives me all 10,000 new customers or 10,000 new sales. Most APIs don't work that way. And so we often have to find the best technique for the published API. And again, we'll do that work. The engineers, the architects will do that work, review the API documentation, determine what's the least impact way to go get data and get data that way. Some APIs only send you one record at a time, for example, and that could be slow, but on our end, what we would probably want to do is run several of those threads at one time so we could get more data. So often we will try to handle that. Most of the time in these systems, the data loads happen overnight. That's not always the case, and especially if you want real-time data and ultimately real-time type processes, streaming services and other things will help us there too. So if we could stream data in from an application that easily supports that, again, we would do that. So a lot of different techniques. There's always usually a pretty good technique for impacting the source data as little as possible. In fact, anything that stops us or that allows us not to have to go to the core database to do it is always bad. And most situations today, you can do that.
That makes sense. Do you have any questions about that?
What about data that is and capabilities area, but might want to unload it? We take it in IDME as archive, like it's a snapshot that has it, and then we can go queries all that. So that the application.
Yeah, you could.
That's one kind of thing. Take it in.
Yeah, so think about So, because I'm familiar with it, right? So with me data, right? So it's sitting in a database right now. I think it's pretty minimal for them to maintain. It's not like, you know, to some extent, it's not like doing this is gonna be some big, huge cost resources you can take it with my data, right? It's really not that expensive, but it's an opportunity cost. Donovan and I were talking about this the other day. It's an opportunity cost, right? That you have to go there because you want to get that data, or the firm team has to do something with it to bring it in, you know. But they don't want to store the raw data. They want what they transformed in the form, right? And so we can take that legacy data from with me and put it in the landing zone or the raw zone and IDME in the state that it was originally created in, right? So if you wanted to see how did this fire get reported in with me in 1999, you could go back and look at that record in that state, right? Want to maintain that, but that would just kind of sit in the raw zone. And then BLM doesn't have to store it anymore, that, you know, that little bit storage they free up or whatever, right? Get some opportunity cost savings. But we start compounding that, right? So we do the same thing with fire staff. We do the same thing with, you know, start changing that. So IDME is intended, that was one of the requirements the community had, is that it is a historical archive. And so we would store that data there and have so it's available for the dimensional modeling. It's available to be utilized with other data that exists in the environment. And so yes, archiving will be something that we intend to do with IDs.
And I imagine that it'll be much cheaper to store it there than in a, you know, standalone application on the server. If it's in the cloud, it's in storage, like very nice.
Yeah. So one of the things about a product like Snowflake, which I like a lot, is that while you pay for storage, you know, like Rochelle was saying, your storage is actually fairly cheap. So you can take a fairly big database, put it over there and just keep it. And if you don't use it, you're just paying for that storage every month. Let's say it's a terabyte of data. You would pay $23 a month, I think, to keep it there. If you don't use it, you're not paying any other cost for it. As soon as you decide to query it, you pay cost for the compute, right? You pay for that compute cost of that query, and that's it. So it can become a storage, a location for what I would call cold storage, right? Or cool storage, where you can put data there. Maybe you don't use it, and 6 months later you do, and there it is, and it's available, right?
So I don't know if you said this, but in the process of putting the historical records into IDME, did I hear, or did you mention pulling those out of the transactional systems that they're currently being stored in now? So they're just storing like the latest or the, you know, the current state of things, or no?
And I think, Brad, you might be able to speak to that in how you're doing this with the data warehouse now, but I would think we would do that. Like, so I know we can think about it from Irwin's perspective, right? So Irwin's been storing all of this data. Want them to be able to offload it and only keep what they think was relevant for their business process. But what they don't need anymore, we want to be able to archive.
So in that case, those records that get moved out, wouldn't the system of record for those old records that you still identify them are in a different place now, they're in IDME, that becomes a kind of system of record. Is that correct?
Yeah, I think it does. And I think that's, you know, that's part of when we talk about, you know, where do you look to get the data and what's authoritative? And it's not as simple as saying, Rock is the authoritative source for research data, right? Like we used to have this money, like we literally have a data standard. The first data standard, Karen?
The first one ever?
First one ever. It was related to, I don't know, anyway.
No, it was,
It's gone.
Yeah.
But I know there are some of our old PDF data standards that had at the bottom, like, you know, the name of an application as the authoritative data source. And it's like, that mindset doesn't really work anymore. And it didn't really anymore then, but we just thought it did. But when you have the same data element that's in 15 different databases, it's like, how, you know, you have to start looking at it at the data element level this is the authoritative data source for this data element at this point in time. We learned that with Irwin, right? Like the CAD system may be the authoritative, well, so this fire code might be the authoritative data source for a moment. But once, WFDS picks it up, then WFDS becomes authoritative for it. And when then form becomes authoritative for it as the final fire reporting system. And that becomes the system of record, but then we're gonna also have it in IDME, which is an authoritative, right? So like some of these constructs we've had about, here's this really nice little box that we're gonna put this in and call it authoritative data source, system of record, doesn't really work the same way that we thought about it in the past. So that's gonna be part of our challenges, is to make sure and part of mapping the business rules and getting the metadata and getting tags and having things documented means that you may go maybe data from a CAD system that's authoritative at a particular point in time, and then it becomes something else, then it becomes something else, right? So those are all gonna be fun things to do.
And one thing I would say too is like, cause sorry, I can't see you, so I'll step out a little bit. One suggestion that I was making these architectures is that anytime we get data and it gets ingested into this architecture, that never goes away. It never gets replaced, never gets deleted, never gets anything, right? I mean, it's always there. And so the advantage of that is, we get benefits of it that we're not really asking for, right? Nobody's really requesting these benefits, but one benefit is you kind of have a pretty large audit trail of data, right? You could look at records in different states over periods of time, and there's a current record, but there's also previous versions of it, right? I think big advantage, right, for a lot of different reasons. Just, I may have mentioned this one of our meetings the other day when we were talking about cloning, but for another client, an Obamacare client, we had to go to a December 3rd, 2019 version of the data. We could, because we had this, right? Because we had every record of it, every version of the record, and we have been taking clones of the data, so we could. And so that was really nice, right? And it was driven by the IRS, so we had no choice, right? We just had to do it. And so the other benefit it provides is that now you have other options. For example, there's a concept of an ODS, like a operational reporting database, where it's not BI, it's not dashboards, but it's just other reporting that you might have queries already that run against your own database that produce some interesting and good proven reports. Well, that can be your ODS as well, right? The data gets moved in there. It stamps every record and says, this is the current version of every record. When you run against the current version, which is usually what an ODS wants to do. And now you have reporting that is much faster and much better and not hitting your source database, right? So, and running on a highly distributed, on a big, massive cluster of machines, right? So I think all those benefits come into play otherwise, right? Like if an ODS was required, I'd just take this landing zone that we've been talking about and say, let's turn that with a few changes into an ODS also. And it could be, so it could be an audit trail, it could be an ODS, it could be a raw storage area for advanced analytics, and it can be a landing zone for further moving the data, for down the line, right? So it becomes a lot of things to a lot of people, and it can be very useful that way if you end up using it.
So originally, when we did, or when your family data warehouse, we did it, that was back when Jamie was project manager, and it was specifically so they could purge data out of Irwin because they only wanted the current and the previous year. I'm not sure what happens if they don't do that now. So we moved everything in there to do that, but then we also built an API. So we pull Irwin data, I think, every minute. So we have all of that in the warehouse, and then we have code which you can report against it. And then we materialize views go against usage on data. And then we have other data such as aviation that we pull in through API. So It's similar to where you could potentially use that as the authoritative data source eventually. The IDME part of it.
Yeah.
Doing that same.
What else? If you don't mind. I will start calling out names. So just sometimes. Hey, Kristen Allison. First name. I think this is one of the first times Kristen's seen this, so I've been getting some chats, so I'm just curious. She might be multitasking. And I'm going to call on.
So to build on what you were just talking about being able to take a snapshot. So for firms, ingesting weather and processing, climatology processing is highly flux. There's a lot of, there's a thought that maybe all of that should stay with firms, but what you just said, when they finish calculating and fire data, et cetera, that if we could take a snapshot of it so that, if I'm understanding correctly, I'm learning a lot more than I understood and asked about what it takes to manage these fires and stuff. But if you had a time in the future then where you did want to come back and say, we made a decision based on a model, and we want to go back and look at what was the data at that time. I'm thinking like originally when IDME was first coming along, we thought, oh, is all of that data processing going to move into IDME? Instead, that was like when we first FEMS was starting, it's like, oh, all that processing that should be part of IDME. And it's built in FEMS right now because we didn't have the environment, but more I'm hearing from you guys, maybe is when you're talking about an application that does part of its data business possible, whatever you call it, would you keep that processing there and then you guys would ETL in and to make those snapshots so you can build that history, to be able to go forward and backwards, or
Yeah.
Thinking that I need to shift in how I'm thinking about
Well, I
this.
mean, I think if it's a done deal or already done, right, I mean, I think the way you said it is fine, right? But, there's two ways to have that versioning of the data. One way is we do it through engineering, where every day we pull data, we build it with a pattern that says, hey, if this record already exists, I'm not going to replace it. I'm going to add a new one. Say that's the current one. Say the previous one's not current one, and put a timestamp on it. So you could always go back and say, I can go back and look at the data at any point in time. On the other hand, data can be just copied and it can live there. A clone of that data can be made, or it changes, or let's say data is being copied on a daily basis. And you say, okay, we hit a particular point in time, it's the end of the quarter, March 31st. We want to take a snapshot of that. We can clone that, and now you have a clone of that. So later on, a year later, you go back, you go, I can look at the data as it was March 31st, or as it is today, right? So various techniques depending on the use case, I guess, right? But the cloning use case is really more of usually I would say it's because a key point in time, like for example, health insurers have open enrollment periods. We take a snapshot of the day open enrollment is, right? Just makes sense, right? Then maybe another snapshot when they start sending forms to the IRS, right? Or things like that. So there's kind of these key points in time for compliance reasons or other reasons that they do it. Other companies do it for different reasons. So I think it depends on the use case. But one or the other is happening because generally speaking, we would already be ingesting it for other reasons, right, for dashboarding, the data anyways.
Right.
So the data's there. Now it's just a matter of saying, do we want to version it? Do we want to snapshot it?
Right, and so this is where then we were thinking, if you guys are gonna be adjusting the data, would it be better, that if the process it did move into, so like we adjust the weather every 5 minutes. Scripted logic and all kinds of stuff, but, my thought was, if we moved it over though, how quickly after you've ingested would that data be available via an API back to users and friends?
Immediately. Yeah, I mean, it's, as soon as, just like any other database, as soon as you commit, you insert data, you commit that data, it's available.
And so like
Now-
the refinement
Yeah.
process, so moving it through the pipeline, that's fast.
Yeah,
right?
well, yeah, I mean, if you're looking at speed, right, new data comes in, let's say the data's committed, there's something waiting for that trigger, right, to trigger the job. The job, or maybe the job's just always running, it runs, and it does its thing and puts it into a refined zone, let's say. I mean, depending on how long it takes to run that transformation, right, but of course, I'm always thinking in this environment, it's gonna run faster than in the application environment, right? If it's a lot of data transformation and SQL type work, right? But depending on what it is. Now, one thing to remember, this is a BI system that's not meant for transactional updates. So I can open a transaction, store a record, commit that transaction. That window will be much bigger than it would be, say, in Oracle or SQL Server or any other data. Because it's not meant for that. It's really not meant to store a record at a time. It's meant to store 20,000 records, 100,000 records at a time. And part of the reason is because as I'm building it on a distributed system with distributed storage, if I get a record stored here, I get a record stored here, I get a record stored on, it's not totally efficient, right? It's just not built for that. But it can do it.
You bring it on the records with the same spot.
Not necessarily the same spot, but it can activate the whole thing at once, right? So it can say, hey, I've got 1 million records and I can send 100,000 of them, and I can split them up into 100,000 groups of 100,000, send those 10 groups all at once to different servers, right? That would be much faster than say doing it in Oracle or SQL Server.
So I have a question in for Emmy. That is, how will people make updates to prior currency prior perimeter? People want to say, why how come now? Let's see, put it into form, and yeah, plug to the system.
Yeah, I don't think the data, like the way that the applications work, or, because of progress, we're not have things.
So there won't be any option for batch upload. If people find it multiple records of groups of records. They're going to have to do it all the time.
Well, I mean, that's the way it is now.
Yeah, I know how it is now. I know at one point they did talk, there was talk there, or that, I should say that functionality was needed. And it doesn't sound like that functionality is going to be there.
Well, I mean, I guess that would probably be on the, maybe the Tuesday subcommittee or not us to decide that. Because it's
Back to the application development,
yeah.
to fix the data rather than.
Well, so I think there's two things. So if you think about the day-to-day work that's done in an application, right? So, IROC, right? So people are there, they're doing resource ordering, they're filling orders, they're doing the work that IROC was designed to support, right? That's the transactional type work that Carlos is talking about. That is not at all what IDME is about. Like, we don't want to do anything related to that in IDME. IDME is about being able to take a whole bunch of that data as those transactions are doing and moving it and transforming it, right? So workflows that currently exist should remain. We're not talking about IDME replacing application components to support use cases. So if you had a record that you knew needed to be updated, then you would go to the source system and you would update it. So that's one aspect of it. The other aspect that I think you're asking about is what if we had a standard, we had collected this data and we had called this attribute this thing, and now we have a change to the data standard and we're changing the name of this field and we want to update all of our data to have this new thing that we want to have associated with records. We could do a transformation like that of the raw data. We could say, oh, we want to change the name of this field and all of these records from, so we still have what it was originally collected as. We could do the transformation and that becomes available for people to use analytically, or we could, make those types of bulk changes that you're talking about, I think.
No,
No?
No.
Okay. Okay.
well, I think it's okay. It can't be like so interesting, but.
I think if the Forest Service had 15 points that they were fire history points that were in the wrong spot,
Yeah.
you would want from 1997, you would want to change those 15 points bulk
Right.
and put it into the informed data set rather than going individually through inspectors.
And the reason I
That doesn't
asked,
exist right now.
yeah,
And I don't think we can fix that.
And I
Yeah, I don't
think
think
we
I can
should.
fix that.
I mean, we're not the authoritative data source. The informed user should be doing that, right? I mean, ask informed.
But if it's Forest Service data.
Who would be the Forest Service user, right? That would make that edit. I don't know. I mean, that's
the problem that we've always run into. And it may be separate, and it probably is separate from IDME. But that was still when conversations were first starting out about going towards a consolidated environment for data storage. One of the things that was asked about, it was specific to fire occurrence and fire perimeter, not to any of the other data sets, but those two in particular, is there will always be points being found from various sources that forests and or BLM or BIA or anybody else wants to update. How do they do that? And right now, as far as inform and perimeters, we go through inform and you can do it one at a time. But I know for a fact that the Forest Service, when they had some of their data manipulated by contractors at the time, there was a datum shift, which affects a lot of points. Now, whether or not anybody's going to have the time to go back and do that remains to be seen. But the question still remains is if there is a need for updating of existing data, how do they do it?
I gotcha. Like for example, when we went 6 decimal points out, right, where we
Yeah.
was only doing 5. And so then everything got updated, not by the user, but by a system.
So there's
Yeah.
known bad data that needs to get corrected.
Yeah, I mean, in this case, we had updated the standard, so it was more specific.
Then changed data.
And we changed the data.
And you did a spreadsheet.
And he did.
Because we talked about this before. Basically, it's a CSV spreadsheet. And we were gonna upload it in Firesat.
Well, this was like, I know of a region that they felt that their data was not input correctly back when it was moved from historical
Yeah.
systems
Yeah.
to newer systems. They felt that there was an error that had occurred to many of their points. So, yep. And
But
so
they had
that's my
that-
question is, if IDME is not the proper location for that, where might that be taken care of, where it's not a one-off situation? Because if it's a one-off situation, I don't see it ever being updated. I don't see anybody having the time or the personnel to go through and fix all those records.
So is that something that we could? I guess we have to know, like, we have to have some way of identifying the records that you want to change. But if we had that, we could like add to the data that's like in there, right? We could,
That'd be part of the refinement.
Yeah, exactly.
yeah.
Yeah.
Just gonna,
Then it would have to be back in.
Yeah, but then it would have to feed back in, because
You wanna-
the whole point is we have a system of record. So is
I'd
that,
say you have to work with the. Take the signatures.
Yeah, I mean, ideally, any
CSV file.
data that's right now is in a search.
Yeah.
Make it
It's like even like full.
yeah.
But
But in the event that the data is taken from the source system and the only copy lives in IDME, then you have to be able to edit, refine it in IDME.
Well, but you could still have a feature in a form that says, I need to make a data update that's only, you can only get to it by authorized people. That you go put in the parameters, that it goes and queries, it pulls it back and go, okay, yes, I need to make changes to this, you can do it and then up. I mean, it's, you gotta kind of do your roadmaps together.
Make certain people able to edit.
Right, that's what I'm saying is, and if you're only keeping a certain amount, just because you're only keeping a certain amount of data in an application space, then doesn't mean your users are now no longer gonna be able to get to it, it just means they have to bring it back.
I mean, it's really the governance rules that right now, where the GIS analysts from the different agencies and bureaus can't take the service, bring in our pro and edit the attribution. It just, that doesn't exist right now, but that's what has to happen.
It's an application.
So you're talking how many records?
That's, Lauren just asked me that same question. I don't know the answer to that. The only way they're going to know it is if, you know, the forests and regions of that were affected, go in and look at their records and figure it out. That's not something me, at being at a national level, would be able to do.
Yeah.
Don't they put that in a spreadsheet? A file? And you have to put all that in someplace.
It did happen, now that I'm thinking about it, it did happen when some of the fire stat data got moved over. But as far as if there's a master record, I think that's kind of taking us offline of where we want to be with this conversation today, but it's certainly something that needs to be addressed at some point.
Yeah, so what we did, this is similar to what we do with NASF data, is the states fill out a spreadsheet, upload it to our FTP site, and then we have a process, ETL, that pulls that spreadsheet into the warehouse, loads it. And then anytime they upload a spreadsheet to that one, doesn't matter if it's has one change in it or not, it processes it and puts it in there. So I think what you're asking is a process like that where you'd have a file and you want to upload it. So there's the ETL process that loads a file.
Yeah, and I think that's I mean, I think the way you guys are doing it is a common practice in these types of architecture, or it should be. Where external data or data that's not within the system, but needs comes from somewhere else, some desktop, some other system that we don't have access to or haven't yet adjusted. Maybe it's some grand totals of some data or other reference data. Yeah, I mean, again, that should always be available, and should be available in a system like this.
Fire Family
It
Plus,
should, yeah.
Fire Family Plus is another one, because it's standalone laptop.
Yeah.
So they have export files.
Yeah.
That they would want to load.
Yeah.
So
Yeah.
don't be doing that one record at a time if you have thousands of records.
All right.
They don't pay you enough.
Hence retirement.
yes,
Yeah.
yes. Right behind you.
So as we've talked about this, have you thought about any data that you would be interested in seeing transformed, or a data problem that you've been kicking around for a while that you're curious about? Lisa?
Yes. I said it last time, I was trying to get a use case for Ross data, and IROC data to merge.
So talk about what that issue is. So because what I want is, I want Carlos and Mike to hear. So just kind of talk about like what it is that the problem is.
Well, so I mean, Ross was in Cognos, right? and that's where all of our historical data was stored. IROC is in service now,
They also have
and we
very,
have no way to meld the two.
Two very different schemes.
But what's?
they have two very different schemas.
Those are means of applications. Look for data.
And just for research. Yeah,
Resource
Ross,
orders.
yeah, Ross is in a database. It's in the Oracle database.
But the structure is different, right? So,
Yeah.
Yeah,
so
completely different.
completely
Yeah.
different.
And it actually goes back to the data draw days because it had one structure and then what's there. And Cognos, there's a lot of things that we changed because we discovered free typing in fields bad, so we changed things. And so you're trying to make a vegetarian salad, you know, but you got these little meatballs in there that are left over from back there and it, trying to make that mesh. Because the data's,
Different.
yeah,
Yeah, here's another one
There's
too.
something, and the other thing, oh, sorry, Greg.
Oh, so one that we're facing is people want fire occurrence data and aviation data. Well, aviation data is managed outside of FAM. It's Forest Service, IBS. So we pull that into the warehouse. We have fire occurrence data. Trying to get that to match is almost impossible because the only same field we have is fire code. Well, in IBS, you can manually type it in. So it's almost impossible to match them up. So in that case, you have a whole different entity that's managing data separate from another one. You have to match them up and you can't get the two entities to work together to make, say, one common unique field.
I think IROC would be easier.
Yeah, so I wanna go back and so like I have some urban legends in my head about Ross data, right? So I think I heard at some point in time that like even within Ross itself, that there were some updates that changed the schema enough that the data isn't cohesive across what we consider Ross.
She know it now, it's like 1990.
well.
You know exactly.
She know exactly the
When
date.
radios moved
Yeah.
from equipment to supply, so before that date, you're gonna go find them all under E's. After that date, you'll find them under S.
Okay, so let's use that. So we have a change in how you would find a resource. So we have a data set that has a resource identified one way, and then at a point in time, it changes the way that is identified. How would IDME help solve that?
Well, typically what we would do is when we're refining data, we, there are rules for refining it. And as much as we can, we try to put those rules in reference tables, other types of tables that help us do mapping. So in this case, for example, we would have a table that would say, pre-1993, map it to here, post-1993, map it to there. And when you saw like Matilda, it's kind of that ETL tool that has pipelines. The pipeline would maybe split and say, okay, pre-1993, I'm going to do it this way. Post-1993, I'm going to do it that way. If there were different business rules or other things associated with it, but typically it would be done there. So when you look at the refined data, you don't have to think about it, right? Like it keeps saying, ultimately, when you get the data, it should be that you don't have to think, right? It's like, oh, that's exactly the way I want to see it, right? It's already been mapped. I don't have to know when that mapping happened or how it happened. It just happened properly. So typically it would be in one of those steps, and either the pipeline that goes and refines data, or the pipeline that goes and creates the analytic zone, typically one of those two places would typically be placed. And then as far as like how that would get managed or things like that, other things like that would get put in there that could be also accessed that way. Right?
And I think one thing is that, the pipelines we've shown you so far in our proof of concepts, because it's a proof of concept, are just like a line, right? But the reality is that these things can be forked and have all kinds of lanes and all, they can get really involved. And so that one rule about that piece of equipment, there could be a dozen other transformations that are happening for different things too. Maybe this is in 1993, this is what happened with it. And in 2000, this is what happened. So it may actually, the same data may go through multiple transformations, right? If it's pre-1993, it gets transformed for that 93 business rule. But maybe there's something else that happened in 2000, so then it gets changed for that 2000 change so that it's consistent with the current data if that's how we want to see it. So those pipelines, we've shown you really simple pipelines that just look like little straight paths, and they can be really complicated. So then it's a matter of sitting down, and so this is where Edge comes in, because we want to collect all of those business rules and have those business rules documented, that this is when a change occurred. In fact, Gabrielle and I were chatting back and forth on Friday. She had created a new collection from the, I think it was the complex incident management.
IPM. Yes.
Yeah. So there was a memo that the industry put out, and it had like this history of things that happen, right? And so we put all of that in Edge, because it's like in, 2004, IFPM was approved for the first time, right? Well, that changes our business processes. So we wanna capture these business rules so that we can reuse them, and then IDME then applies these business rules to the data. So if we know that there are changes that occurred in the data schema for resource data in Ross in 1993, we want to capture all of those business rules and all of the changes that have to occur to make it correct with the next set of data, the next data schema. And then if there was a change in 2000, then we'd want to take that 2000 data and be able to transform it to the 2001 schema, right? So each of those steps would have to be, we'd have to look through and capture those business rules for what happens for each data element, and then it gets applied to all of the data.
I would say too, the most common scenario, well, not the most common, but a common scenario that is the most extreme of that is when the system gets swapped out, right? That, you're using Salesforce for CRM and you go to, Oracle right now for CRM, right? Or something like that. In the end, when I have a CRM system and I have a customer calls in, we open a ticket, I just want to see how many tickets I have, right? It doesn't matter what system it came from or anything like that. I mean, how many tickets did we have last year? How many do we have this year, right? How are we tracking? And what a ticket is in one system is completely different than another system, right? Or the ACA client I talked to you about a few minutes ago. So they want to know how many people enrolled. How many enrolled last year? How many enrolled this year? Well, 3 years ago, they swapped out their enrollment system for a different system. But when it gets reported from a BI point of view or any type of trending to state governments, to CMS, to the IRS, it just looks like it's an enrollment, right? And so all the mapping of the source data has to take place in these pipelines so that in the end, these enrollments look the same. Now, when you swap out a system, you're usually swapping it out for more functionality, so they may not have all the same attributes. So you have to account for those missing attributes from one system or the other. And again, we try to account for those in different ways by having dimensional fields that might be unknown in certain cases, or might say, not applicable to this system or something like that. But generally speaking, that's the case when you swap systems out. You're swapping it out for a better system and hopefully more values, but those values didn't necessarily exist before.
Well, even if you make a change to application, because this happens to us. IBS will make a change to aviation, they won't tell us. Then we get a call from the user saying something's not working, and then we track it down. And they decided to add 2 fields that we didn't know about. So there has to be this collaboration.
So
Those changes.
And there's I always say there's no magic, right? They can easily break what we're doing, right? We do try to put in as many checks. There's a concept of data observability today. So you can kind of monitor the systems to see, am I running against the right system? Am I getting the right data? For example, those kind of things, what we've gotten used to now is saying, well, let's put in checks for that. So if they didn't tell us, we'll still know, and we can at least report it to ourselves. Or if something happens, let's say every day I'm pulling over 5,000 records and today I pulled 2. Well, the observability system will catch that and say, you know what, that doesn't fit the pattern. There's something wrong, right? And so before that data gets reported, we know that we have something to look at because something changed. they stopped using a field that we used to count on, right? And we always look for a 1 or a 2 in that field. Now there's nothing there.
So looking at the chat, so I think Andrew had asked, keep the NIFC open data site and link from the data mart or be duplicative. I think we dealt with that. Not looking to replace something like that. DJ asked, can outside resources be linked? In Minnesota, they have geospatial commons with data. So we can point to data anywhere, right? That becomes part of the governance process for us to decide, is this data that we want to include in the marketplace? And so in the marketplace, I think it doesn't necessarily have to be stored in one place, right?
Yeah.
So we can put it in there so people can find it. So Steve had chat in here. You have a big chat in here. Okay, maybe we won't talk about that one.
Susan has one.
Susan.
I just put in 2 things in the chat. One was just another example use case because I've been dealing with the fire perimeter history, and this is a problem that I've seen across that data. Inconsistent use of unique fire identifier and trying to match those up to the fodder IDs. It's really challenging, and I could see a system like this automating that to get us down to like filtering it down to a handful of ones that need to be reviewed by agencies or parks or districts rather than, you know, some sort of bulk upload where the district tries to fix it all and then does a bulk upload. Instead, proactively say, here's a subset of problems we found, help us fix this. So that was that comment. And then the last point that the gentleman made about, you know, proactively monitoring for these changes. That's something that at WFMRDA with WFDIS and IFTDIS, we have been looking for some solution to say to us that this endpoint has changed and it's not feeding us the data we expect it to. I don't want to know that when my application breaks or when my user reports it. I want to proactively monitor a dashboard that says, hey, there might be something suspicious going on here. I need to look at this now. I think that point is really crucial, and it's something that's really sorely needed as we move into this, you know, service environment where we're consuming downstream services that we don't have much control over.
I think that's like a more modern concept of making sure the data is good before you actually let like somebody see it, right? And in the past, we often would bake in or put in those kind of tool checks ourselves, right? As engineers, we might do a minimal kind of check to say, does it look like I'm getting the right data? Or does it look like anything has changed? And in today's world, there's actually kind of like the marketplace tools, there's an option to go with data observability tools. They're fairly immature at this point, but they do allow people outside of the engineering world to put in rules. And these rules will say, you know, stop this from running. If, you know, Rochelle was talking about these complex pipelines. Well, a pipeline might have 75 steps and multiple paths. It might say, stop this from running if at any point in time in this process, we get 0, you know, view records of this type of record. And it'll monitor those kind of things and stop it from actually showing that data out to the outside world. And that can be monitored or done through like a lot of business rules and things that people can type in, you know, and on their own to say, I don't want this exposed to the world if it doesn't meet this criteria. Again, fairly immature area, but it's out there. And like I said, in our case, what we typically have done, we would typically put those kind of rules into a system. And you know, I always make the joke that we get called because the system failed on Christmas. Well, it's because nobody's buying or enrolling on Christmas, right? Or, you know, And so the rules worked because nothing happened, right? But I don't want to get called on Christmas either, right? So those kind of things can allow people to manage it better as, again, this thing gets bigger, more complex, more data. You know, product owners or business area owners can say, in my area, I never want this dashboard published unless I have 10% more data than I did last week. Or something, yeah, whatever your rule.
One of the things we had talked about is like, so we talked about the time dimension, right? The dimensional model for time. So we talk about like how somebody would use that. So how would Inform use that? How would the Open data set use that? And like, what is that? We've gone through all of this work, transformed all of this data. Now we have this new shiny data. Like, then what do people do with it?
As far as
Application, like if they wanted to make that to use that dimensional model to enhance the data that they're provisioning for their application.
well, typically, I think, you know, the best way for an application to use the dimensional model is when they need to use a measure or a metric that's being produced by that model. Because that measure or metric is not only based on its own data, but maybe other data it may not have access to, right? So at that point, it could say, like the time dimension, it could say, you know, for this particular time span, did this measure exceed a certain number? And that might be interesting to an application, right? Or those kind of things. But it would always be in concert with the fact data that it's, you know, that's using that time dimension. If somebody wanted to use that time dimension, like kind of externally, they could. I'm not saying I really suggest it, right? But they can. They just have to kind of honor the foreign key concept, I think, in that time dimension. And they can make it useful to themselves, right? If they wanted to code against it or write code that makes good use of it, that, you know, benefits from it. And as long as you honor like the data structure and the design of it and use it the way it's intended to be, it works, right? So even if I store, you know, a transaction in an application and I want to point it at the time dimension, I could kind of virtually do it by saying, okay, I'm going to use the right foreign key, point it at the time. And then by joining those two together later, you would actually get, again, those powerful results that you get with a fact table. I don't know that I kind of recommend it maybe in a one-off basis, but it'd probably be better for that data to first come into the data lakehouse and then the pointing to happen there, right?
So it's not like if I have an application, all I have is epoch time. Say for like resources and when I send them out to the field. It's not like I could just point to the time dimension and it would make a field that says local time. I mean, I know, but like.
You could do
then
it.
I use it.
Yeah, you could do it as a lookup, or you could do it as a, like I said, you could grab the foreign key and keep that foreign key. Then later on, when you join them together, it works, right? You'd have all the value that comes from it. But again, it's all kind of foreign key based, right? So having foreign keys across databases is somewhat problematic.
And I think what's important with the time dimension is using the processing we're doing to get the local time zone rather than using the time dimension table itself. So maybe how do we expose that processing to the other applications rather than that table itself? Where they can give us a point and a time and we spit back, this is the offset, for example. I think there's more value in that than exposing just that one table.
Okay. And so what would that look like then? So they would just make a call to IDME and get something back?
Yeah, I think so.
Chris?
I don't know, this might take it a slightly different direction, but that kind of reminded me of, what if you had several applications out there that happen to use fields that have the same pick list or domain values? It makes sense to store it in a place like IDME as the authoritative source where it's being updated, governed and maintained. And the applications are tapping into that to use rather than storing that domain in separate applications and having to update those domains.
Yes, that is part of our goal, and actually, so that's where Edge comes in, so if you think about it as a process, so Edge is the data governance tool that, that the data stewards that are responsible for that data, so let's, incident position, name and code, right? NWCG, incident position, name and code. So there is an NWCG committee that's responsible for that. And so they were using Excel spreadsheets to manage that and emailing it around different versions, right? So now they're using Edge. But we know that Edge it's a data governance tool, right? It's data geeks and most people aren't going to be in it the way that, you know, folks like Gabrielle and others are. And so, so our thought was to do just what we did in this proof of concept in that they brought the current list of incident position names and codes from Edge, so it's linked to Edge. So if the governance committee goes in and makes a change, that update gets made in IDME. But I think that the marketplace concept is probably, I don't know, we're still, I'm getting into your territory now, but we're still exploring some of this, right? And figuring out like, what is going to be the easiest way to support applications using reference data. So as we start moving forward, then, you know, like in an ideal world, any application that needed NWCG incident position names and codes would go to a single place. Working through, but that's really leads to like some of the conversations that we're going to have tomorrow. We'll talk about organizational data, frequency data. You know, we're really starting to move into managing reference data. And in managing reference data, the whole power that, excuse me, is that there is a governance process that manages it, right? And then we want to be able to edit it in one place, have everybody get those updates at the same time, have everybody be using the same lists instead of, you know, 4 columns abbreviated 3 different ways and 3 different databases that, you know, gets confusing. So yes, that's the goal. And so kind of some of that relationship between Edge, where we're governing the data, and IDME, where we're exposing the data, we're still kind of thinking through some of that, but we've proven with that concept that we can make it available in IDME. And, you know, so we'll keep working through that.
And so with that, there are implications for all the application teams and changing their framework to adopt rather than importing or having that stored in their system, however that interface works, reaching out to IDME, which is fed from Edge to get that.
Yeah.
Yeah. Part of the evolution for everyone.
Yeah, I mean, that's why these conversations are so important, right? Because as we start thinking through this, this has implications over time, and to have folks in here starting to think about, oh, when, you know, what data is actually in my application that is actually reference data. And so reference data is data that doesn't change as a result of operations, right? So you don't, NWCG unit IDs don't change because we have a fire. Right? They just exist. And so it's kind of that slow data that doesn't change very fast. And so we've got those, all applications have that, right? So it's not a problem as long as you don't, nobody wants to use your data with somebody else's data that also has that data. So organizations are the big one that we're going to talk about tomorrow, because lots of applications have stored their organizational data. And when we always have this at urban integration testing, there's organizations are always a component of the conversations that occur in integration testing. Because it's like, oh, what did you call this unit? Oh, well, we have it in here as this. And in exchange, it doesn't work, right? So organizations are a big deal. So as we keep talking about this, building out these reference data sets, then the goal is that applications start using them and getting the benefit of that. And that is a change to the way that their data is structured, their applications function.
And I was going to say, the original reference architecture, because I want to remind myself, so I brought up that we showed Rochelle, what, about a year, well, I don't know if it was a year ago, but almost. So master data, MDM, is in the middle of the raw zone and refined zone, and the refined zone and another zone, right? I think what we were calling the formatted zone, which I think we kind of combined in this other architecture. But, so again, in this concept, master data is always needed for reference purposes. We would need it, right, to produce the measures, metrics, and other things that need to be done in this type of system. On the other hand, is it the right place for that to be the central repository for applications? And again, I'm not going to make that decision for every other application out here, but remember that the intent here is not to build a system that delivers a record at a time, right? You know, even if, like, say if you were to make a request of this system and it delivers a measure to you, it might be one value, but that measure maybe came from 1 million or 10 million or a lot of it, right? A lot of data that came together. But essentially a master data reference is still only a record, right? So typically, again, for efficiency purposes, this system is not efficient in that way, right? It's efficient in aggregating 10 million rows of data, right? And comparing them and doing that. It's more efficient to do a single row type delivery from some other, you know, from a traditional Postgres MySQL database and deliver it out to everybody else, right? That way, or something along those lines, right? I mean, I'm not gonna say what the solution is, but, you know, just keep that in mind.
I know Jill had her hand up. I just want to like go over the epiphany I just had from this watching. Because we keep going around and around about like, right, like, well, we've had conversations about, is IBM or Irwin doing the same thing, right? I think that explanation right there just really solidifies why they're not doing the same thing, right? Irwin is about one record out there. You're acting on one record and you're doing something with that one record, where IDME is about the aggregation of hundreds of records, right? Or data from hundreds of records. So that it's a really subtle thing, right? I mean, that's, as we keep talking about this, where we keep spiraling down a little deeper, a little deeper, a little deeper, and we start peeling back what those nuances are, that's really easy at the first level to go, oh, that's the same thing. But it's listening to Carlos is always like, oh, that's what that means. Now I think I understand it differently. And that was one of those moments. It's like, oh, okay, it's one record versus the results of aggregation of a whole bunch of records.
Right.
Yeah.
Write it down.
I know.
And, you know, and just to make the example clear, for example, you guys are all using what we call MySQL or SQL Server. If I were to say, you know, select star from customer table where customer ID equals 8943862, right? The way that would work in those systems is I would normally have an index on that ID. I would do a lookup in that index. It would probably do about 3 different reads. It would point to my record and there it is, right? In Snowflake, that query is read, if I have 100 million rows in that table, that query is reading 100 million rows. Because it's built to read all the data every time. That's the way it works. Well, I know it sounds kind of funny or kind of weird that it's fast, but because it's built to read all the data every time, it makes everything really fast because it splits it up into multiple CPUs and multiple clusters. But again, it's not expecting me to run that query, right? That's not the query I'm driving. It's really expensive to do it if I'm doing that query.
So it doesn't have indexes then?
What's that?
If that makes sense.
It does not have indexes. It actually runs faster by reading all the data every time.
Boy, it wasn't an Oracle.
I know. So for example, you know, it creates these partitions. Each partition generally has about 400,000 rows. Each partition is on a different disk. And if it can say, you know, if it can split that up into say 300 partitions, that's 120 million rows. And if I can run all 300 at one time, it can run through 120 million rows in 2 or 3 cycles.
And that does it automatically,
Yeah,
so it deviates.
you don't have to tell it to do that. Yeah, it doesn't matter.
And you don't have to like partition.
You
it.
don't partition, yeah, you don't manually partition.
Oh. Good.
So it's a little bit of a change in mindset, right? Like Rochelle said, right? You kind of have to change that way of thinking.
Jill, you remember?
You're thinking I still remember this. Mine was an add-on to Chris's. Chris was talking about how some of are trying to maintain that same set of values for where possible for specific fields. Well, I've known that this is also true. And that is that we have the same field names with different values in them and different ideas of what they mean. For example, we use the word, or we used to use the field address in dispatch boundaries, and in GAC boundaries. And in one, they have the entire written address, like 1109 South 6, Norfolk, Nebraska. And in the other one, they have just the 1109 South 6, and then Norfolk is in a city field and Nebraska is in a state field. And getting those all aligned is going to be also a challenge, depending on which data sets you're working with.
Yeah, and that's actually, the conversation that Lauren and Chris, the session they're gonna, it's related to that session on the business knowledge blueprints and the work that Gabriella's been doing in Edge, and just being able to start just getting really specific, like, you know, if we have in the NWCG glossary in the past, it had multiple definitions for the same term. And so Gabriella's been breaking it out, and there's a particular methodology that we're using and formatting that we're using that will be able to have a term, and then be able to see that that same term has 3 different versions or is used in 3 different ways, right? But you have to, that's that part of documenting the data clearly enough that humans and machines can understand it. And if we document it clearly enough that machines can understand it, it actually makes it easier for us humans. We think we can understand it because we can make all kinds of assumptions when we see a word, but you know, we may see a word and we're going to get 10 different assumptions about it out of this room, right? Because we all have a different lens. And so trying to reduce that ambiguity in what it is, how we're defining something, the terms we're using for something, and then how we collect that as data. So it's kind of this process of what is the business, what is the term, what does it mean, how do we use it, what are the business rules, how do we apply that as data, and then how the IT application is built to support that. And we have to do all 3 of those things really, or we end up with exactly what you're talking about. That's why we ended up with that, right? Because we didn't have a consistent vocabulary that we were using that had low ambiguity, and we were able to apply enterprise-wide. Okay, so I think we're coming to the end of our day. So this has been great. I hope it's been helpful for you. I have appreciated the various questions and conversation, and please, if you have more questions, Carlos and Mike are going to be here. We can, their contract is coming to an end at the end of this month, so we've only got a few more weeks with them. So I would say take advantage of the opportunity to get their expertise and their perspective, obviously govern. And so if you think of questions tonight, you have other things that you want to ask them, please do so this week. Okay.
All right, wrap up. So what I have for notes is ran through the action items. DMP will work on their processes to intentionally work on some of the items. Super P and Patricia had some ideas on that. Carlos reviewed IDME conceptual and the physical architecture. Mike walked us through the Matillion data pipelines. Snowflake Dimensions, the Harbor Data Marketplace, and creating data products with disparate data sets. John and Tricia outlined the IDME roadmap and plans for getting data from the source system. We skipped the breakouts due to a lack of individual rooms, but had some really great discussion on IDME and just all of these concepts. Rochelle teased the discussions for tomorrow on reference data, edge IDME, and how other applications will interact. And key takeaway on difference between IDME and Irwin would be single record versus an aggregation of all the records. Anything else? Nope. People? Nothing.
Amazing job.
All right. So looking at our agenda for tomorrow, we do have it set up to be starting at 0900 again. So we can go ahead and get here and do whatever you need to do, check email, get ready for the day, and then we'll start at 9. Any other notes?
Just, I think, you know, those conversations about organizational data, frequency data, those are important conversations for us to have. Our goal is to actually transition the organizational data. And so if you haven't been part of those conversations, we want to make sure you're up to date on that so you don't get surprised. Yeah, so I think tomorrow's going to be a great day. Keith and Chris are going to share some stuff about NASF and data, and that I think there's a ton going on there that we all need to be aware of, because I know Chris and I were talking the other day, there's some folks in Forest Service that I think are trying to replicate some of that, and so like how we get word out about what's going on in so. And then dinner at Stone Brewing. That'd be fun.
Any notes from online? How was the camera's audio for today? You okay?
It was all right.
11:13.
Yeah, I
It
thought
did
it sounded
get-
good.
Yeah, there was some glitchy periods, but it was fine.
Yeah, I heard nothing all day.
If you were sleeping, listening, doesn't mean that.
We assigned everything to you.
That's right.
Great job.
Right. Thank you, everyone.
Thanks, everyone.